Okay, welcome to JC Connect. In the previous class, we were discussing about the tests on brakes. Uh, I think we have covered the different types and what is the designation also. We covered it. Uh, so today we try to complete all the tests, and at the end, I'll show you some of the model test reports. How exactly the test reports has to be submitted and how exactly it has to be tabulated, and whatever the tests we have discussed till now, okay, how exactly it should be compared with the norms, okay, especially um, in India, how exactly we are giving. Okay, some of the popular NABL laboratories are giving um, the standard formats of the reports. So even if you are an practicing engineers, okay, you have to tabulate it in a same manner, and finally you have to say that, okay, what exactly the quality of the materials. Okay, so this we covered it. So of course the tests on brick that is common, that is compressive strength. So normally whenever you are carrying out the compressive strengths, so always take um, more than four or more than five numbers of bricks. Okay, in only one brick you cannot decide. Okay, what you have to do is that you have to take the bricks randomly. For example, if you have around 100 or 200 bricks are there, always you have to select the bricks in a random way. Okay, so then once it is selected, okay, normally 5, minimum it is 5 it is required. You can go to maximum. Finally you have to take the average of that. Okay, and especially their dimensions has to be measured, remember. Okay, so normally it will be of the same size, but still, whichever the specimens you have taken, it is better to measure the dimensions. Then immerse in water about 25 degrees centigrade, 25 to 29 degrees, 24 hours. So then surplus moisture, surplus moisture is allowed to drain and frog if any is filled with a mortar, 1 is to 3. So it is kept under bag for another 24 hours, after which it is immersed in clean water for 3 days. Okay, 3 days you have to pack it. Then at the time of testing, these bricks are removed from a water, wiped dry, and place the flat surface between the um, plywood sheets, each of 3 mm thickness. Okay, so then of course the same UTM you have to use it, and the load you have to apply it. Okay, see the method of the immersing and all those things. It is that um, even during the rainy season, if the bricks are undergo, if any bricks are undergoing any of the uh, compression, or whether it is going some of the elongations, if it is immersed in water, okay, whether it is dimensions are increasing or not, okay, that we have to test it. Okay, and one more thing, whenever any peoples are, if they are constructing um, the house using the bricks, normally they will soak it for in water, so that the binding will be uh, is will be um, like more. Hmm? So if you soak it and if you provide it, so binding property normally it is going to increase. Okay, so that also you have to check it out. And one more thing, in this test, soaking in water, it is an advantage for the um, construction of the buildings. Why? Because normally the constructions are the brick walls and whatever it is there. Normally they are going to construct in the rainy seasons, so that even if it is exposed to an uh, rainy season, it should not affect. Okay. And one more thing is that any dead matter, if it is attached to that um, brick, that has to be removed if you soak it in water. Okay. So then water absorption, simplify bricks. Finally, what you have to do when you are test on brick. So five all compressive strength for all five has to be done, and average will be calculated. Remember, okay, average will be calculated. So even whenever, even if you are finalizing this is the strength of the bricks. So always you have to prefer five bricks. The five bricks taken for a test, they are allowed to dry for oven. Remember, okay. Why you have to dry in one means, so most of the moisture content has to be removed. Moisture content has to be removed. Otherwise, you won't get exact moisture content. Suppose if it is already absorbed, for example, if it is soaked in water, if it is already absorbed the water, okay, then no point in how much water is going to absorb. Okay, then you have to take the weight. Usually takes place in 48 hours. Then they are cooled at room temperature. Then W1 is measured empty. Then they kept it in clear water at 29 degrees centigrade 24 hours and wiped dry with a damp cloth and weight W2 is measured. Okay, so once it is kept it in water for about 24 degrees centigrade, then taken out and final weight is measured. And the difference in the whatever the weight gained after keeping it in the water, that has to be measured. Okay, if you want, you can find out it in um, in terms of percentage. That's also possible. Okay, then the fluorescence. So here also you have to take the five samples. Then and bricks are placed vertically in a dish 30 centimeter by 20 centimeter approximately in size with 2 centimeter immersed in distilled water. The water is allowed to be absorbed by brick and evaporated through it. Okay, so uh, if it is nil, okay, there is no perceptible deposit of the salt. So if it is slight, means when it we can say it is a slight. Okay, so it is not more than 10% of the area of the brick is covered with the salt. If it is a moderate, so when you say it is a moderate, it is heavy deposit, heavy deposit covering, heavy deposit covering up to 50% of the area of the brick. The heavy means, if it is heavy means, okay, the heavy deposit covering more than 50% of the area of the brick. So of course, um, a fluorescence, it is nothing but it is a crystalline or salty, crystalline or salty deposit that normally it is going to occur on the surface of the brick. Okay, see some of the white kind of things it is going to accumulate. Okay, white powder type, that we can call it as efflorescence. Okay, of course it also depends on the kind of water you'll use it. Okay, it depends on the kind of water. See why they was suggested the distilled water here is met. If you use other seawater for example, definitely the salt accumulation will be very high. Check the property of this. Always you have to use distilled water, so that in distilled water no ions will be there. No ions will be there. Okay. See, sometimes it is going to happen, sometimes it is a property of the bricks also. Okay. So then dimensional tolerance. So what I already explained that even if you soak it in water, is there any variation in the dimensions is going to happen? So that also you have to randomly check. Okay. Um, plus or minus 3% for the class 1 and plus or minus 8% for the other classes is allowed. Then hardness, how exactly you are going to check it? So scratch is made on the surface of the brick with a fingernail. In wood brick, no impression will be left. Okay, this you have to remember. Then soundness. So two bricks are taken and each other in hand. Then they are struck with each other slightly. A clear ringing sound should be produced and brick should not get break. Okay, so there is a simple test you have to conduct um, whenever um, you are going through and um, testing on the bricks. Okay, see some of the test reports. You can see that. mm, yeah, see this is before that. Before that, one thing I wanted to explain is that test on steel. Okay, one is physical test. We will conduct it. Physical test. And the second one is chemical test. So related to this, I'll supply later. So in the physical test, elongation test will conduct in chemical test. So what exactly it consists of? The how much iron will be there? So how much traces of the oxides? Okay, so that will be there that we are going to conduct it. So physical means how much it is going to uh, change its dimensions when it is applied for an load. Okay, chemical test means what kind of chemicals it consists of. Normally your steel. Okay, how much proportion of Fe is there, how much proportions of other trace metals. Normally even it consists of small percentage of Cu also. Okay, copper. Okay, whether how much percentage of carbon is there. Even carbon also, it is a main component of the steel. So how much carbon is there, how much iron is there, how much um, oxides of iron is there. Okay, so all the tests are we are going to conduct it in chemical test. Okay, for this we'll use the XRF, that is X-ray fluorescence, and we will use what I explained already one in the previous classes, that is EDX followed by XRD. Okay, of course this is a little bit more accurate than these two. Here we'll get elemental. Normally XRD will be preferred, will not be preferred. So first XRS will be used. Okay, even we have some of the titration methods are there, but these methods are not accurate to determine the tests on steel. Of course, you know the elongation test. We already covered how exactly elongation of the materials can be calculated. Similar, you will use the gauges, different types of gauges. Based on that, we will find out it. Okay, we'll supply that materials later. Okay, so then you can see some of the test reports. Standard. Um, this is the physical uh, test reports on reinforcement of the steel. Okay, see here whenever if you are giving any of the test reports, remember that. Okay, See here, the first one, you can see it is the source of the sample. Very important. You can see here it is sample supplied by the consumer. Always you have to write the first one, whether you brought it or whether it is sample supplied by this. This is the first statement. Always you have to remember. Suppose if you have collected it, okay, you collected from where you are collected, and you have to mention. If you are collected, you have to mention latitude, longitude, place where exactly that you have to mention, and what kind of building component. For example, if it is constructing the beam, okay, so mention it for it is constructing the beam. If it is for the column, mention it is clearly for the column. Okay, so whenever if you are calculated from where and what kind of quality it is, means who has supplied it. For example, whether it is TMT 500 or whether it is TMT 550. Okay, so that always you have to mention. Okay, then it is sample supplied by the consumer. Once the sample supplied by the customer or the consumer, means it is almost 50% of the risk is over, because he only supplied it. But always nowadays the methods of testing is has been changing. Why? Because most of the time what will happen is that sometimes he will supply the uh, good quality of the steel for testing, but whenever he is placing in the field, it will be totally different. Okay, then so he has to give the one letter saying that what exactly where work you are, who has given that, so that little number you have to, and when it has been given, okay, to you. So that is a reference number. Okay, so then when you have conducted the test, so that also you have to write. Okay, what exactly the project location site. Okay, for example, construction of super specialty hospital at the premises of Belgaum Institute of, this is Medical Sciences, Belagavi. Okay, this is the latest one. um, uh, um, I took it from the some PMC. I know some PMC, and we used to give the test reports to them. Okay, so then this is um, that is project management consultants, PMC. Okay, then what kind of grade it is? You can see here it is FE 500. Okay, then condition of the sample, you have to, it is satisfactory, that you have to write. And very important, see, test method, what you have followed, so that you have to write here. Okay, so test method, which code you have applied. Okay, and which version it is, very important. So IS 1608 part 1 2018. Okay, then IS 1599 2019. Okay, IS 1786 208. Okay, so then it is reconfirmed. Okay, that is 2018. Okay, so these are different brands. Okay, so then you can see the tensile test, how much exactly what diet is there. Okay, then this is the requirements. You can see at the downstream, you can see how much elongation is there as per the requirements of 17 IS 1786. Okay, as for the IS 1786, which are the requirements. Okay, and finally, okay, we can see that elongation is 25, 24, 21, 21. Okay, and these are all mass, dia, then minimum, what kind of grade it is, whether it is FE444415 it is, how much it is there, FE 500, so FE 500D. Okay, so elongation minimum. Okay, and final remarks, always once it is done, the remarks you have to say that the test samples confirm to IS 1786 to requirement for AP 500 grade with respect to the physical test conducted. Okay. Note the results are leads only to the sample tested. This always you have to write. Okay. Whatever the things are there, it is only the given samples. Okay. Always it is like a safer side. Always you should be in a safer side that whatever the material they have supplied it for them, you have conducted it. That statement you have to make it. Okay, then so this is all the complete and authorized signature and everything. And of course, see here at the top you can see this is NABL accredited lab. So as for ISO, so if it is NABL, so it has to be certified by ISO par so 17025. Okay, this has to be certified. Okay, this is one typical kind of the tests on steel reports, and others I'll show you. Okay, these are the um, tests on the cement. Okay, here also you can see that. Okay, all the things it will be there. So the name of the PMC. Okay, here you can see in this report the name of the PMC, name of the client, the name of the agency, the what work. Okay, you can see how exactly the test reports has to be specified. The tests on different properties of cement. Okay, so specific gravity. So then uh, it is sample test is, but as for the IS code, what it will say is 3.1 to 3.15, and fineness. Okay, by what method you followed, that is Blaine's using Blaine's apparatus. Okay, so then it is 290.76. Always you have to write the units also, and what is the IS standard, how much it will be there, so not less than 225. Okay, then fineness, uh, cement, then normal consistency. Okay, soundness, so settling time, initial settling time and final settling time. Okay, and compressive strength. Okay, finally the remarks, the test sample conforms to the stipulations specified by IS 269-2015 with respect to physical test. Okay, so then this is very important. The last one, temperature during testing. So many things we discussed. Temperature definitely it is going to affect a lot. Okay, then these are the test reports on fine aggregates. You can see here you have to classify whether it comes under zone 1, zone 2, zone 3, zone 4. Okay, percentage finding, cumulative sieve analysis. Okay, this is modulus. Then manufacture sand and sand properties. Then these are some of the tests on coarse aggregates. Okay, for only 12.5 mm size coarse aggregate. Okay, normally for different sizes So how much cumulative percentage? So single graded. These are standard reports. So whenever if you are giving any of the reports, always you have to follow the standard protocol. Okay. So test samples confirms the requirement of graded size aggregate as per IS 383-2016 with respect to the gradation test conducted. Okay. So here also you have to write who is the client, what is the agency, the reference number, all the things you have to write. Okay. This is the completion of your the different tests on aggregate. Only one small part we have left. That is, they have to consider the rate analysis. So I'll try to take some of the uh, manuals or PWD rates that I'll supply and how exactly it has to be considered. If that is done, you're going to complete the second module. So we calculated only the quantity in the previous module, okay, but we have not considered the rates. Okay, how the rates has to be considered. So that will take um, one or two classes, and we'll try to uh, complete this module. Okay, and the third module is will take hardly 5 to 6 hours, very less. Okay, syllabus is very less. We'll move on to the fourth module soon.